In this AWS Redshift system overview, we will go through Redshift system architecture view, how Redshift achieves extremely fast query execution. Then we will recap what we learned before you take your quiz. Let's take a look on Redshift system architecture view. The request is coming from client applications, for example, ETL tools and BI OLAP applications, through JDBC or ODBC drive to Redshift cluster. Redshift cluster is a set of nodes which consist of a lead node and one or more computer nodes. The lead node is a SQL endpoint with metadata that correlates with query execution. The computer nodes hold columnar storage of data and operate the actual MPP queries. The computer nodes access S3, EMI, DynamoDB, SSH, etc. to load, unload, backup, and restore data. The type and number of computer nodes that you need depends on the size of your data, the number of queries you will execute, and the query execution performance that you need. I'll show you how to determine the total number of computer nodes when we are on the cluster node types section. Redshift creates one database when you provision a cluster. This is the database you use to load data and run queries on your data. You can create additional databases as needed by running a SQL command. When you provision a cluster, you specify a master user who has access to all of the databases that are created within this cluster. This master user is a super user who is the only user with access to the database initially. Through this user, you can create additional super users and users. You will see more details during our hands-on labs. Inside each computer node, it is partitioned into slices. Each slice is allocated a portion of the node's memory and disk space, where it processes a portion of the workload assigned to the node. The slices work in parallel to complete each operation.